Hi kids, in this video we like to perform some transformations on the exponential function. Remember, the exponential function was a function of the type y is equal to b to the power of x. Now, we've studied these transformations before, the transformations a, h, and k, but to recap really quick, to review, h, as you recall, is in charge of translating the graph to the left or to the right. So h is in charge of translating to the left or to the right. And as always, if it's a horizontal transformation, we want to be careful with the signs and the actions. So we're going to keep in mind that h comes with a negative sign in the formula. K is in charge of vertical translations, that's shifting up or down. And A has two jobs. The sign of A determines whether there's a reflection over the x-axis or not. And the size of A determines whether you have a vertical stretch or a vertical compression. So if A is greater than 1, again, we're talking about A without its sign. So the absolute value of A greater than 1 means a vertical stretch. The absolute value of A between 0 and 1 means it's a vertical compression. So A's sign determines whether we have a reflection over the x-axis, a vertical reflection. And the size of A, the value, the absolute value of A, determines whether we have a stretch vertically or a compression vertically. Here's our example that I chose for today. Y is equal to 2 to the power of x plus 1 minus 3. So right off the bat, we identify that h is -1. So that means we have a shift of 1 unit to the left, and k is -3. That means we have a shift down of 3 units. So our parent graph, our parent exponential curve, which by the way we've already identified as a rising curve, it's an increasing function, is going to be shifted 1 to the left and 3 down. So that's the outcome at the end. Having said that, we'll make a table of values, plot the points and graph, and then quickly discuss some of the characteristics of that function and its graph. So let's start with 0, which is always probably the easiest number to plug in. In this case, it turns out it'll be -1, but 0 is always still easy. So with 0, we're going to get 2 times, since x is 0, we get 2 to the power of 1, 2 to the power of 1 minus 3. Well, 2 to the power of 1 minus 3 is equal to -1. So 2 to the power of 1, 2 minus 3 is -1. So at 0, we get -1. That's our y-intercept. When I plug in 1, 1 plus 1 is 2, so I get 2 squared minus 3. Now that's 4 minus 3 is 1. So when x is 1, we get 1. So 1, 1. When x is 2, 2 plus 1 is 3. 2 to the power of 3 minus 3. 2 cubed is 8, 8 minus 3 is 5. So when x is 2, we get 5. When x is 1, 2, we get 1, 2, 3, 4, 5. Fast growing function. The right end behavior is infinite, positive infinity. -1. -1 plus 1 is 0, so 2 to the power of 0 minus 3. 2 to the power of 0 is 1, 1 minus 3 is -2. So at -1, we get negative 2. Negative 1, negative 2. Negative 2. Negative 2 plus 1 is negative 1. Negative 2 plus 1 is negative 1. So 2 to the power of negative 1 minus 3. Minus 3. Now, what is 2 to the power of negative 1? Again, we discussed last time. The negative sign flips the base over, and then you just use the power. So if I find the reciprocal of 2 is 1/2. 1/2 to the power of 1 is just 1/2. 1/2 minus 3 is negative 2.5. So again, 1/2 minus 3 is negative 2.5. So negative 2.5. I could have written that as negative 5 over 2, negative 2.5, or negative 2.5. So at negative 2, we get negative 2.5, negative 2.5. Okay, so those are all the points I'm going to plot. But do I need any other information is there any other info that I can use to help me graph this to see a better picture? Well, yes. I do know that we have a shift of 3 units down. I do recall that the horizontal asymptote for the parent graph was the x-axis. Well, if the horizontal asymptote for the parent graph was the x-axis, and this thing is shifted 3 units down, well, now the horizontal asymptote is y is equal to negative 3. So I'll shift 3 units down this horizontal line, the horizontal asymptote, shift it down 3 units, I'll go down to negative 3, and I know I have an asymptote there. And we always want to draw or graph the asymptote with a dashed line, telling ourselves that, hey, our graph is going to get closer to it but never touch. Well, this actually does help, because now I know that I'm going to get closer and closer to this line. So I'm going to start from here, kind of come get this guy, get that guy, and go up. So there is the graph of our function, 2 to the power of x plus 1 minus 3. Again, plot. We usually, in our classes, we say plot 5 points if you can. Plot 5 points, and usually we start from 0, but if the horizontal shift is more than 2, I'd probably be a little more careful with what number I'll start with. But then that's for you to battle and practice and see what you can get out of. So let's talk about some of the characteristics. We already talked about the horizontal asymptote being y is equal to negative 3. So y is equal to negative 3 is our horizontal asymptote. By shifting 3 units down, did I change the range? Well, of course I did. The range of a parent function is numbers greater than 0. Well, I shifted everything down 3 units. So now the range is numbers greater than negative 3. So the range of this function is the set of numbers negative 3 to infinity. It's really important to see how the range did change because we had a vertical shift, right? But did the domain change? Absolutely not. I don't care what you do to an exponential function, what kind of transformation you perform, whether you do reflection, stretch, compression, shift right, left, up, down, the domain doesn't change. The domain of an exponential function is always all real numbers. Which means when I go pick my x's, I'm not worried about picking the wrong one. I'm never going to pick the wrong x because the domain is the set of all real numbers. There is, as always, no maximum value, no minimum value. And there is an x-intercept. It looks like it's between 0 and 1, but do I know how much it is? No. For me to figure out what the value of that x-intercept is, I have to study the inverse of an exponential, and then furthermore solve the equation this expression is equal to 0, which at this point we can't solve. But there is an x-intercept, and of course there is a y-intercept, which we already found. There's always a y-intercept. I hope you have success with your example in the book, and I'll see you next time with logarithmic videos. See you then!